All right, let's go ahead and start going over this. For number one, listen to me very carefully because I said this on, I emphasized this on Tuesday, and I feel like maybe not everybody watched the notes video all the way through. Can you mess with the theta over 2 or the plus pi over 3 yet? No. Think about when we did logs. These are all together, and we're taking the tangent of it. So it's like an argument, right? So what do we have to move first to be able to get to that theta? Tangent. So what's the opposite of taking the tangent? Tangent inverse. So does everybody agree? We're going to be left with theta over 2 plus pi over 3, and it's going to equal the tangent inverse of 1. Okay. So y'all are good with that first part. It also looks like Ross, my internet is lagging here at school. So we're all going to have to be patient today. Are y'all okay with the very first step? Okay.
I have one question. I'm so confused with the inverses. What is, like, why do we still just find regular tangent? Like, why?
That is inverse tangent. So we're looking for an angle where the tangent is 1.
That's all it.
Yeah, that's what inverses mean. We're looking for an angle, right, y'all? Okay, so what angles on the unit circle have a tangent of 1? Pi over 4. And what? There is another one. Good, and 5 pi over 4. So in quadrant 1 and quadrant 3, oh, let's do pi over 4. In quadrant 1 and quadrant 3, the tangent will be positive 1, right? At that middle angle, that pi over 4. I know what you're going to ask me. Does everybody agree at that middle angle? The tangent will be 1 because the y and the x are the same. You divide them, you get 1, okay? Now listen to me carefully. On Tuesday, I told you that when you do the inverse first, you don't need to write both options. Some of you did not believe me, or you asked why, or you just didn't remember me saying that. So I'm going to show you why. Does that make sense? Which one of these do you have to write? The first one. Because technically, tangent inverse means we're looking for an angle between what and what? Negative pi over 2 and pi over 2, quadrant 1 or 4. So this is the one you have to have. Are we okay with that? Okay. So let's solve this equation right here. If we want theta, I'm going to move this for now. What would I need to move next? Pi over 3, you would subtract it, right? All right, and then this is where, bless y'all sweet little hearts, we are not good with fractions. Yeah, I'm going to show you how to subtract or add these fractions because this should not be hard. To subtract fractions, what do you have to have? Common denominator. What's the common denominator between 4 and 3? 12. So what do I multiply 4 by to get 12? So you multiply the bottom by 3 and the top by 3. What do I multiply 3 by to make it 12? So you multiply the bottom by 4 and the top by 4. So now what is 3 pi minus 4 pi? Negative 1 pi. Good. So now we have theta over 2 equals negative 1 pi over 12. How do you get theta by itself? Times 2 to both sides, right? Okay, everybody look at this. What's going to happen here with the negative pi over 12 times 2? Negative 2 pi over 12, which reduces to, good, negative pi over 6. That is the solution we got from our equation. Is everybody okay with that part? Are we sure? Because I still got some of y'all trying to move the pi over 3 first. You cannot do that. It is inside the argument. You have to take the tangent inverse first on this one. Okay? People at home, we're okay? That was your question, right? Earlier? Yep. You were like, why are you doing both? You told us just to do the one. Look at your interval. Is everybody looking at this interval? Is negative pi over 6 between 0 and 2 pi? Nope. So you need to find an angle that is equivalent to negative pi over 6 that is on this interval. What angle is equivalent to negative pi over 6 on the interval 0 to 2 pi? Very good. Okay, look at these children. 11 pi over 6 should have been your answer.
Wait, what? Oh, what happens to 5 pi over 4? What do you do with that?
I moved it. You don't write both. I'm about to show you why you don't write both. Is everybody okay with us solving it equal to pi over 4?
Because you only use one, you don't use. Wait, does it matter which one you use?
It does. If you're taking the tangent inverse, it's an angle between negative pi over 2 and pi over 2. Yep. So you only want the one in quadrant 1. Let me show you what would happen though if you take the one in quadrant 3, because it's nothing bad. People at home, y'all are still with me, right?
Well, I have a question.
Okay. Yes.
So, like, when we started this, if it's a problem like this, if it's cosine or anything at the beginning, and then there's two things in parentheses, do we just take the inverse of it and move it to the other side?
Yep, you have to take the inverse first if you're trying to get to the argument. Even if it's not two things, KJ, even if it's this. My Drake, you did this. You cannot multiply that by 2 first. You have to take the cosine inverse first because this is the argument. You can't even get to the argument until you get rid of the cosine, okay?
Okay.
All right, let's look at the green now, y'all. If you decided, or if you forgot, or if you were like, I'm just not going to listen to Miss Poole because that girl's crazy. She don't know what she's talking about. And you also set it equal to 5 pi over 4. Please just watch what's going to happen, okay? If you do theta over 2 equals 5 pi over 4 minus pi over 3, that's going to be 15 pi over 12 minus 4 pi over 12, so that'd be 11 pi over 12. If you're like, what the heck did she just do? I subtracted fractions, got a common denominator, okay? I just didn't write it all out. Now look at this, times 2 times 2. I hope we're all watching. 22 pi over 12 reduces to 11 pi over 6. Now, do you see why I told you you don't need both if you're taking the inverse at the beginning? They will always end up equaling. So you can do both. You're going to do extra work. Huh? It is a good way to check yourself, but I'm also going to show you today how to check yourself in Desmond's. Is everybody okay with that? If you're taking the inverse as the first step, you need to follow your inverse function rules. So just look for the angle between negative pi over 2 and pi over 2. You don't need the one in quadrant 3. It's going to end up being the same. Because tangent repeats itself every pi radians or 180 degrees. Good job. Is that all like starting to come together? Does that help, Kendall? Okay, good. All right. The second one, people at home, we should have been even better with because that one really was not very challenging. There's one similar to this on your test. It didn't disconnect. Y'all. Ross, you see my internet being slow? He may not even be up here.
Yes, ma'am.
Yeah, there he goes. Screen sharing has stopped. I'm sure it has. Fart head. Sorry, y'all. I don't know why Pitt County Schools internet is being slow today. I think this is the slowest it has been all year. Like, look at my little rainbow spinny. Maybe. Here we go. No, I don't think it thunderstormed last night. It's supposed to thunderstorm today. So y'all pray for me because if it's doing this in Math 1, them boogers are just going to leave. I just know it. All right. What do you do first in number 2? What will we move first to solve for theta? So does everybody see how this one does not have an argument? The argument is theta. There's nothing else in there with it. So for this one, you can go ahead and subtract the 2. And then we'll get 3 square root of 2 cosine theta equals -3. Are y'all okay there? Okay. What would my next step be? Divide 3 square root of 2. Divide the whole thing. Is everybody okay with that? Because 3 square root of 2 is what's multiplying by cosine. That's extra work. Why would
That's what I did.
just do it all at once?
It's just easier in my brain.
Okay. Kids are weird. Love y'all, mean it. All right, so look, you can divide it all at once. What happens with the 3's? They make 1. So does everybody agree this is going to be cosine theta equals -1 over square root of 2? Yeah? Was that a Kevin? Okay, can you have a square root of 2 in the denominator? No. So what do we do? Rationalize. So everybody look at this one. For number 2, what you're really looking for after you rationalize. Can you guys tell me what it would be after I rationalize? Good, Kendall. It would just be negative square root of 2 over 2. So we're looking for all the angles, not just the one, because we're doing this at the very end. I want every single angle. I'm going to say it one more time because half of you aren't looking at me. I'm not taking the cosine at the beginning. I'm taking it at the end. So I want every single angle between 0 and 2 pi where the cosine is negative square root of 2 over 2. So let's think about it this way first. What 2 quadrants are the cosines negative in? 2 and 3. Where the x is negative, quadrant 2 and 3. So now think about square root of 2 over 2. Where, at what angle does that x value occur? The pi over 4. So what are the 2 pi over 4 angles in quadrant 2 and 3?
Pi over 4.
Good. 3 pi over 4. Good, KJ. And 5 pi over 4. Those are your 2 answers, solutions. Y'all okay? KJ, good job, babe. Anybody at home have questions before I move on? Anybody in class? Chris, how you doing?
I'm still trying to catch up.
On this?
Yeah, I'm just writing all
Okay.
this down.
That's fine. Anybody have questions? Yes, ma'am.
So the general form would be 3 pi over 4.
So the general form of this one, great question, would be 3 pi over 4 plus 2 pi k and 5 pi over 4 plus 2 pi k. You would need both of them because these aren't 2 pi away. It's quadrant 2 and 3. So every single time around the unit circle in quadrants 2 and 3, we'll get that negative square root of 2 over 2 for the x value. The first one would have just been 11 pi over 6 plus pi k. Good questions. Anybody else at home have questions?
Really not that far. Okay, never mind.
All right, so you can put this on the same notes as Tuesday because we're still solving trig equations. So I'm still on page 38. And we're just going to amp it up a little bit. So this would be example 5. You should have lots of examples of these in your notes. So we should be good. All right. Do you guys remember on Tuesday we did a factoring one? Do we need to see another factoring one, or am I good to go ahead and amp it up?
I want to see one.
Okay. We'll do one more, and then I'm going to amp it up. Yes. But I didn't go over it, So this would be a good way for people to check themselves. It's also very similar to the one we already did in our notes. All right, does everybody agree with this one, that it is a trig equation, but it looks like a quadratic? How do we solve quadratics? The most efficient way, the fastest way, is to factor. So, one more time, factoring. Let's just do a review, actually, because y'all are about to see some of these, and I'm going to be so upset if y'all can't factor. How does x squared minus 4 factor? Good job, y'all. X plus 2, x minus 2. Do y'all remember from Math 1 what that's called? I'm looking at you because your brother just learned it. Difference of squares. It's a binomial. Good, Kevin. They're perfect squares. Square root of x squared is x, so you need 2 x's. Square root of negative 4 would be plus and minus 2. We know how to do that, right? So on your classwork, when you see something like this, no one's going to freak out, right? Square root of tangent squared would be tangent, correct? What's the square root of 1? Plus or minus 1. So that's how you would factor it. That's how we factor binomials. So y'all are good there, right? Okay. Factoring trinomials, you still look for factors of the first and last term, but they don't have to be perfect squares. So what are your factors of 2 sine squared? Very good. 2 sine theta and sine theta. 1 sine theta. Right? Okay. What are your factors of negative 1? A plus 1 and a minus 1. So we just need to figure out where the positive should be and where the negative should be. So to do that, you look at your middle term. I want it to add to give me a negative sign. So which one needs to be negative? Where does the negative need to go with the ones? Good, right here. Why are y'all saying right here? I agree, but somebody be able to tell me why. Good. When you multiply back out to check yourself, when you FOIL it, the negative needs to be with the 2 so that when I add positive 1, I end up with negative 1 in the middle. So it does go in this back one. Does that help people at home who are struggling on this one on the homework? Because some of you did struggle, and that's okay.
So we just look at the middle term.
You look at the middle. So whenever you're factoring a trinomial, you take the factors of the ends and figure out what will add or subtract from those factors to give you the middle. So I teach my Math 1 kids and my Math 2 kids, you're making a sandwich. When you make a sandwich, you always start with the bread. Then you put it together with the middle part. I always have one kid that tells me they start with their turkey. I'm like, you slap your turkey down on the counter? No, you put it on bread. Look at your factors on the ends. Figure out what will add and subtract to give you the middle. Okay? All right, from here, once you've factored, what do you do with each of these factors? Set them equal to 0. Good. So this is going to be 2 sine theta plus 1 equals 0. I see you, Taryn, coming for your extra credit. And sine theta minus 1 equals 0. So now you're just solving them both, right? Subtract the 1. So this will be 2 sine theta equals negative 1, right? And then you would divide the 2. So are y'all okay if I skip to this? Negative 1/2. And this one would be sine of theta equals 1. We're okay? I'm just making sure we're good from Tuesday. Where on the unit circle, any angle, because this is at the very end. We're not doing inverse trig to start, at the very end. Where on the unit circle are the signs going to be negative 1/2? First, tell me what 2 quadrants. What 2 quadrants are the y's negative? 3 and 4. Now use your hand trick. Figure out what angle has a sign of a half. Pi over 6, I agree. 1 finger below would be that first angle, pi over 6. So what are the pi over 6 angles in quadrant 3 and 4? 7 pi over 6, good for quadrant 3. Remember, the numerator should be 1 more than the denominator. And 11 pi over 6 for quadrant 4. So there's the 2 solutions for this part. Now there's going to be at least one more. Where on the unit circle is the y value 1? Good. Don't miss that one. I always have kids miss that one. I'm like, are you freaking kidding me? It's the top angle. It's 90 degrees. The ordered pair is 0, 1. Right. But they always miss that one. You best believe I put one of these on the test. Don't miss it. So these are the 3 angles where this equation would equal 0. All 3 of these. So on the test, you'll just list all 3 out. Yes. So go ahead. I'm going to let you talk. Go ahead. What do you mean reciprocal? So sine inverse of -1/2. If we're doing inverse functions, we only look in quadrant 1 or 4. When we're solving equations, if you're not doing the sine inverse till the very end, when you solve an equation, you are finding every single angle. All angles that make it a true statement. If it's at the very end when you're solving, your inverse function rules don't apply. Nope. Good question. Very good question. Are y'all okay? All right, can I amp it up now? Sure, let's do it. These are my favorite because the children freak out. I'm gonna give you 2 of these. Yeah.
Oh, you ever gonna ask this after
Nope. You literally only factor cubic functions in math 3. It's not really useful for anything else. I don't like factoring those either. I use Desmos. When I'm tutoring my math 3 kids, I'm like, did they tell you it was non-calculator? They're like, no, we can use a calculator. I'm like, great. Go to desmos.com. See where the graph crosses the x-axis. I hate factoring cubics. All right. This one's a little tricky. Ah, let's see, Maddox. Does everybody agree that you should probably distribute the 6 first and then move everything to one side? Because it says squared, so it's going to look like a quadratic, right? Okay, so let's do that first. Maddox, you're on to something. I just don't want you to give it away for everybody. So now are y'all okay if I move all these terms to the same side? So that would give us sine squared theta. What would come next? -6 cosine, good. -6 equals 0. All right, we're going to take a field trip back to math 2 very briefly. Don't write this down, and I'm just comparing it. Can you factor that? Why not? It's not because it's 2 different variables, though. There's no factors of x squared that would ever add to just give you a y in the middle. The factors of x squared are x and x. So there would have to be an x in the middle. Right? I think that's what you meant, Kevin. So this won't factor. So what Maddox asked, he said, wait a minute, are we going to have to use the stuff we used where we could only mess with one side? What are those called? Identities. You absolutely could get an equation where you have to put in an identity. I love these. They combine all the 3 things. What can we rewrite in this equation? Okay, be careful. You cannot touch the cosine. It is not squared. Okay, Kevin, keep going. You're right. Look at him go. Does everybody agree you can rewrite sine squared as 1 minus cosine squared? We should all be saying yes. That's one of the easier ones to remember. Why can we do that, Kevin? What's that called? Look at him go. I'm so proud of you. And then you can bring everything else down. Since it's not proofs, you don't have to justify. Yep. Is everybody okay? Chris, you okay?
Yeah.
Okay. All right, so are y'all fine if I go ahead and combine my like terms over here so I can make it look like a quadratic? So I got negative cosine squared theta minus 6 cosine theta, and then 1 minus 6 would be negative 5. Okay. Anyone at home, if you have questions, unmute and ask. Then this is the next part that y'all always forget, and it makes me very sad. This number keeps calling me, and I don't know who it is. Right, you cannot factor with a negative. You should have learned that in Math 1. I'm going to relate it to our country right now. What happens if you have a negative leader? It makes all the people negative, makes the government, the government's negative anyways. Y'all, our government is freaking corrupt. Until somebody stops voting for someone besides a Democrat or a Republican, our government is trash. That's my opinion. I'm not going to like persuade you, but that is like, that's an outsider's opinion. I'm very middle ground. It just kind of sucks right now. But if you have a negative leader, if you have a negative leading coefficient, you have to take it out before you can factor, because it makes every sign look the opposite of what it really is. So I hope we learned that in Math 2. That's the corny way I teach it in Math 1. Are you done, Kevin? Oh, I thought he said he's done. I was like, wow. Now can we factor it? Yeah. So I'm not even going to worry about the negative if that's okay with y'all. I took it out. It's gone. Are we okay? Factors of cosine squared are what? Cosine and cosine. What are my factors of 5? 5 and 1. If I add 5 and 1, do I get 6 since this is positive right here? If you add 5 and 1, you do get 6. So we need a plus 5 and a plus 1. And now can we solve it? It's just sitting out front. But when you set it equal to 0, so this is like an understood negative 1, right? Does negative 1 equal 0? So it doesn't, you don't need it. It's just gone. Good question though. That's because you took Math 2 online. You probably were never shown that. There you go. Now you know where the negative goes. Right, but you actually don't need it because that's like negative 1 equals 0, which isn't a true statement. All right, so if I set both my factors equal to 0, do you guys agree we're going to get cosine equals negative 5 and cosine equals negative 1? I just skipped a step. I set them both equal to 0. Are y'all okay?
Oh, yeah,
Good, stop. Say that again. Negative 5 is not on the unit circle. Now, my people at home, listen very carefully. What is the biggest number that you can reach on the unit circle? 1. What is the smallest number you can reach on the unit circle? No. Negative 1. Remember your graph of cosine goes up to negative 1, or up to 1, down to negative 1, up to 1, down to negative 1. It is never going to be negative 5. That is not on the unit circle. I'm going to show you in a second. If you type into Desmos, y equals cosine of x, and then you type in y equals negative 5, they don't ever cross. There is no solution on the unit circle or anywhere in math where the cosine is going to be negative 5. So this one doesn't even work. Where is the angle where the cosine is negative 1? Pi. So the answer to this long tail equation is just pi. Just pi.
All this math just
You did all this math just to get pi. I would love some pie right now. Apple pie? Yes, they do. All right, people at home, how did y'all feel about this one?
I'm okay with it.
Okay, she said, I'm okay with it. Good. Goof, Natalie. All right. Can I show us now? Do we feel like we could do another one of these? Like, do I need to put another one, or y'all can work on the classwork and be okay? Okay, can I show you before you move to the classwork how you could solve these in Desmos? Okay, so I'm gonna switch my screen to Desmos. In Desmos? Nope, that's what I'm doing right now. All right, in Desmos, you can check yourself on these by writing the equations into Desmos. So everybody just watch. I'm gonna do the one we just did. It said sine squared equals 6 cosine theta plus 1, right? So type in each side to Desmos. I'm hoping you learned this in Math 1. Sine squared, and I'm gonna put x's. So there's y equals sine squared x. That was the left side of the equation. Then I'm gonna click a new box for the right side, and I'm gonna type in 6 parentheses cosine x plus 1. Are y'all okay with that part? Okay, so we're looking, the solution is gonna be where these two cross. Is everybody with me there? So look where they cross between 0 and 2 pi. They cross at pi. Isn't that what we got when we solved it by hand? People at home, y'all okay?
Yeah, man.
Okay, so I want you guys, we're gonna do this one together. If it were me, I would absolutely write it down in my notebook. So that's how you can check yourself. Do I need to show us how to check ourselves on another one, or y'all are okay? Like if it says 0 to 8 pi, you could just keep clicking till you got to 8 pi and see where all they cross, okay? Example 7 for your notebook. We're gonna solve this one using technology, and I'm gonna talk to you about why we need technology for this one. Oh my God, that was ugly. Cosine x plus x equals 2. Everybody write that down in their notebook. You do not have to write this next part unless you want to, but I just want to show you. Does everybody agree it looks like this has 3 terms? 1, 2, 3. Which would make us think it would look like what kind of function? A quadratic. So everybody just watch. I'm going to try to set it equal to 0. See if I can do anything with it. So you would think it would be a quadratic. Is it? Nope, which means we cannot factor. You also can't solve this. Let me show you why. If you try to subtract the x to get the cosine of x by itself, then you got to do the cosine inverse of, what would that be, 2 minus x? This is supposed to say equal. You should tell me that. That would be helpful. I accidentally erased it. If you subtract the x, does everybody agree? Then we would have cosine of x equals 2 minus x. And then you'd have to take the cosine inverse of 2 minus x. Is that possible? No, because you don't know what x is. So anytime you get one that won't factor, or it's not on your unit circle, what should you go do? Go put it in Desmos. So there is one on your test that says solve using technology. because you can't find it on your unit circle. So everybody watch how we're going to solve this one more time. What they gave me was cosine of x plus x equals 2. I'm going to take the left-hand side, put that in as y equals. Then I'm going to take the right-hand side, put that in as y equals, and I'm going to see where they cross. We learned this in Math 1, I hope. It was called systems of equations. Maybe. So y equals cosine of x plus x. Doesn't that look crazy? You'll learn why it looks like that in calculus if you take calculus. And then y equals 2 was the other side. So everybody look. The solution is going to be where they're equal. So what is the x solution for this equation? 2.988. And you would just round it how they tell you to round it. We feel like we could do that? People at home? Good? Yay or nay?
Yeah, I'm good.
Okay. Don't look at my horrible Math 1 grades. Let's look. Yeah, we're not going to talk about it. They also, half of them used photo math on the test and didn't think I would check their work and see that they used photo math. I always look at it, Kevin. Let's see. Where is y'all's work for today? Here we go. All right. This is not homework. This is classwork. You have 20 minutes. You should be able to do this in 20 minutes because you can check yourself in Desmos and some of them are dirt easy. So I just want everybody to look at this. You're going to get on Delta Math, do this as classwork. Your homework, you should have already started your test review. If you didn't, just remember that whole test review is due tomorrow at 9:30. Okay? I don't care when you do it as long as you get it done by 9:30 so you can join Zoom. You have 7 equations to practice. You do need to turn in shown work on Canvas. But look how easy number 1 is. Subtract the square root of 18, divide by 6. Does everybody see what I'm saying? Now, I do want y'all to look at what Delta Math is asking you for. The degrees. So find the radians, and then how do you convert it to degrees? Backwards. Times 180, divide it by pi, so the pi goes away, okay? So really just take the fraction and multiply it by 180. Get rid of the pi. We think we can do that, correct? Okay, so you have 7 in the classwork. If it was me, I would start with 6 and 7 because these are the harder ones, y'all, where you have to use identities. But this looks just like the one we just did in the notes. Okay? So I do want you to do this because some of y'all seem to be struggling with equations. So I want to make sure we're good because that's about 1/3 of your test on Monday. And then when you finish, make sure you turn in the shown work for your classwork. This will also be an easy classwork grade because some of y'all need a